This question says, use the graph of y equals f of x to answer the following question. What is the y-intercept of f? A y-intercept is where the graph crosses or touches the y-axis. We have our y-axis here, which is the vertical axis, and we can see right here is the point where the graph crosses the y-axis. So this graph has a y-intercept of 0, -5. This question says, write the standard form of the equation of a circle described below. The circle should have a center of 1, -6 and a radius of 9. So we need to keep in mind what the standard form of a circle is. And the standard form is x minus h squared plus y minus k squared equals r squared, where h and k are the center of the circle and r is the radius. And that's exactly what we were given. We were given the center, so we'll let h be 1 and k be -6, and r is given to be 9. So I'll substitute these values into the standard form and get x minus 1 squared plus y minus -6 squared equals 9 squared. This gives me x minus 1 squared plus y plus 6 squared equals 81. And this is the standard form of the equation of a circle with center 1, -6 and radius 9. This question says, find the x-intercepts of the graph of the function without graphing the function. Our function is f of x equals square root of x plus 35 minus square root of x minus 5. So to find an x-intercept, we're going to let y equal 0. And in this function, f of x is representing y, so we're going to let f of x equal 0. So when I substitute a 0 in for f of x, I get 0 equals square root of x plus 35 minus square root of x minus 5. This is a radical equation or a root equation. And the technique for solving radical or root equations is to isolate the radical, and then you're going to get rid of the radical by squaring both sides. So I'm going to start this problem by adding square root of x on both sides. Actually, it might be easier if I do the other one. So I'm going to subtract square root of x plus 35 on both sides. Just a little less messy. Negative square root of x plus 35 equals negative square root x minus 5. I'm going to go ahead and get rid of all those negatives. If you multiply a -1 on both sides, that turns into x square root of x plus 35 equals square root of x plus 5. And now that I've got this radical isolated on one side of the equation, I'll get rid of that radical. This particular radical is a square root, so to get rid of a square root you would square both sides because squaring and square rooting are opposite operations. So I'm going to square the left-hand side and also square the right-hand side. On the left, the square root and the square would cancel each other out, giving you x plus 35. And on the right, I would need to multiply this out. Square root of x plus 5 times square root of x plus 5. And I'll continue up here. We have x plus 35 equals, and I'll multiply this out. Square root of x times square root of x is x. Square root of x times 5 would be 5 square root of x. And we have 5 times square root of x, which is 5 square root of x. And 5 times 5 is 25. I can combine like terms. These two terms are like radicals, and they would combine to be 10 square root of 5. I'm sorry, that's 10 square root of x. Then you still have a radical in your equation. So you would have to repeat that process over again. What process I'm talking about is we isolated this radical here. We isolated this radical, and we squared both sides to get rid of it, and you can see that it's gone. But as we did our simplification, we still have another radical, so we're going to repeat that process again. We're going to isolate this radical, square both sides to get rid of it. So I'll subtract x on both sides, and I'll subtract 25 on both sides. That gives me 10 equals 10 square root of x. I'm going to isolate that radical by dividing by 10 on both sides. This gives me square root of x equals 1. And then I'll get rid of this radical by squaring both sides. The square root and the square cancel each other out, leaving me with x, and 1 squared is 1. So we get x equals 1. We still have one more thing to do here because with radical equations, whenever you square both sides, it's possible to create what was called extraneous solutions. So we need to check to make sure that this works in the original problem. So we're going to check to see if this statement is true right here. We have 0 equals square root of 1 plus 35 minus square root of 1 minus 5. That's 0 equals square root of 36 minus 1. Square root of 1 is 1 minus 5. 0 equals 6 minus 6. And you can see that we have a true statement. So we can say that 1 is the x-intercept of this function. 1, 0. This question says graph the equation 4x plus y equals 3 by plotting points. We're going to complete the ordered pairs in the table below. So we're given the x coordinates. We need to find the y coordinates to be able to complete the table. And then we'll use those points to graph the equation. So in the first row of the table, we're given an x value of -2. And we'll substitute that into our equation. 4 times -2 plus y equals 3. This is -8 plus y equals 3. We'll add 8 to both sides to get y equals 11. So in our table, we would write the ordered pair -2, 11. In the next row, we're given that x equals -1. We'll substitute that into our equation to get 4 times -1 plus y equals 3. This is -4 plus y equals 3. I'll add 4 to both sides to get y equals 7. So our ordered pair in the second row would be -1, 7. Then I'll let x equal 0. Substitute 0 in for x to get 4 times 0 plus y equals 3. 4 times 0 is 0. And 0 plus y is y. So we have y equals 3. And our third ordered pair is 0, 3. Then we'll let x equal 1. Substitute 1 in for x and we get 4 times 1 plus y equals 3. That's 4 plus y equals 3. We'll subtract 4 on both sides to get y equals -1. And our ordered pair in the fourth row is 1, -1. I'll use these ordered pairs to plot on the graph and then draw a line that connects those points. So my points are -2, 11, which would be here, -1, 7, 0, 3, and 1, -1. You can see that those points are falling in a straight line, which is what we should expect. Since our equation is a linear equation, we have x to the first power and y to the first power, and I'll connect these points with a straight line. So we've graphed the equation 4x plus y equals 3 by plotting points. Classify the given function as a polynomial function, rational function, or root function, and then find the domain. Write the domain in interval notation. So this function is g of x equals square root 7 minus x, and we would classify this as a root function since it has a square root and a variable underneath that square root. So this is a root function. Now more specifically, this is an even root. So because our function has a square root, instead of, for instance, a cube root would be odd. When we say even and odd, we're talking about the index on the radical. With square roots, we don't write the index down, but that index is a 2. So with even roots, we do have some restrictions. And our restrictions come from the square root of negative numbers. The square root of a negative will produce an imaginary number or a complex number. We only want to produce real numbers. So square roots of negatives are restricted values because we only want to produce those real numbers. So if we only want to produce real numbers, we want what's underneath the radical to be positive or what's underneath the radical to be 0. So when we're finding domain, we're going to take the expression that's underneath the radical. So for this example, that's 7 minus x. And we're going to create an inequality. And our inequality is going to take into account the things that we want. We want what's underneath the radical to be positive or 0. So for what's underneath the radical to be positive, we're going to write greater than 0 because those are positive numbers. And then for equal to 0, we'll put the bar underneath. So we have the greater than or equal to symbol. And then we'll solve this inequality by subtracting 7 on both sides. That leaves me with negative x is greater than or equal to -7. And I'll divide both sides by a -1. And when you divide an inequality by a negative, you need to reverse the inequality symbol. And we have x is less than or equal to 7. So this will be our domain. But remember, we want to write our domain in interval notation. So I'm going to draw a picture of the number line to represent this inequality. We'll mark a 7 on our number line, and I'll mark it with a filled-in dot. And the reason why I'm marking it with a filled-in dot is because it can equal 7. So that's going to be part of our domain. And then we want to shade the values that are less than 7, and those are the ones to the left of 7 on the number line. And from this graph, we can produce the interval notation. Interval notation will give you a lower bound and an upper bound for that interval. So for this interval, the lower bound is negative infinity, and the upper bound is 7. We separate those values by commas, and we're either going to put a parenthesis or a bracket on these values. The parenthesis and the bracket are telling you whether that value is included or not included in the set. Infinity is not a number, so we'll never include it in the set. Infinity is the idea of it going on forever. And 7, in this case, we would put a bracket on that because 7 is included in the set, just like we made it with a filled-in dot because it was included. So our domain for the function g of x equals square root 7 minus x is negative infinity to 7.